Another interaction that happens because of the Earth, Moon, and Sun is the tides, and this happens because of the gravitational pull. In this one, you're looking at a picture of low tide where the water has gone out of an area, left some boats beached. So once again, it's the tides of the daily rise and fall of Earth's water. So we're looking at where the water kind of gets pulled by the gravitational pull of the sun and the moon, and it's going to move the water in the ocean to different locations, which means that it's not going to come up as high on some locations when the water's being pulled the other way. So high tide, obviously, is when the waters come in and the water level goes up, and low tide is when the water goes out. We don't see tide, so while gravity pulls on all our bodies of water, we really only see it in the areas where it's big enough to actually move around quite a bit. You know, technically the gravitational pull is acting on swimming pools and things like that as well, but that body of water is not big enough for us to actually see tidal pulls. So this is pictures of the same area where we've got our high tides and then our low tides. So once again, it's that interaction between Earth, Moon, and Sun. So there's a gravitational, every body has a gravitational pull. The sun's obviously is the strongest of this three, of the Earth, Moon, and Sun, and then the moon, and then, or excuse me, and then the Earth, and then the moon. So depending on how Earth, Moon, and Sun are lined up, is going to tell us whether we have really high tides or low tides. So once again, while the sun has the biggest amount of gravity, the moon is closest to us. So proximity, actually, when it comes to gravity, being closer actually has a greater influence. The moon actually really influences our tides because it's so close to us, even though it doesn't have very much of a gravitational pull. What it does make are these gravitational bulges, and that's where our tides tend to be higher or lower, is on that side where we have the higher bulge, or we have that part where the water is kind of getting pulled, because the water is not firmly affixed, it's not firmly attached to the surface of the planet, so it's going to move around. The continents, on the other hand, are not going to move because they're firmly attached. So on the side where we have the moon, we're going to have a greater pull, and that's where we're going to have that bulge. But as we rotate around, it's going to cause the water to move as well. So we're going to have a couple of different ways where the water can be. We can have high tides, we can have low high tides, we can have high low tides, and low tides. So here's our high tides. They're going to be closest. They're going to be on the side closest to the moon. And our low tides are going to occur where we're at a 90-degree angle to the moon. So when we have all the sun and moon and earth lined up in one direction, we're going to have the greatest high tides. So in the center picture here is where the greatest high tides are going to occur, because all that gravitational pull is going in one direction. When we have the gravitational pull going in opposite directions, we don't get quite as high of tides. So in some places, the tides are very noticeable, and then sometimes they're not. But we're always going to go through 4 different tides during the day. We're going to have 2 high tides, and we'll have 2 low tides. And you can see that the heights of those tides can vary. And like I said, that's going to be based on, a lot of it is topography. So it's how narrow the area is where the water's coming into, how deep is that area. So there's different attributes of the coastline itself that's going to really determine how dramatic those tides are. So in this diagram, what we're looking at are spring tides and neap tides. When we said that as the planet and the moon and the sun are all lined up together, that's where we get our highest tides, because the gravitational pull is all in the same direction, and those are called spring tides, and that's where we get our highest high tides. Neap tides occur when the moon is at a 90-degree angle with the earth and the sun, and now there's a kind of a splitting of the way that the gravitational pull is going, and so some of the gravitational pull is going this way and some is going this way, and so we get lower tides during the neap tides. These happen during the phases of the moon. That's why the circles are colored in the way that they are. So this is happening at the new moon, where we can't see the moon at all. Okay, our neap tides are happening at first and third quarters. Spring tide also happens during the full moon. So our spring tides are higher and lower than normal tides, so these are our strong tides. When we have our new moon here, we're going to get our highest high tides, and when we have our full moon here, we're going to get our lower than normal tides, because now we're going to have the gravitational pull being pulled this way and being pulled that way. Neap tides, once again, are occurring in between that, so they're happening when the moon is at that 90-degree angle between the Earth, moon, and sun. And these are our weaker tides, because once again, that gravitational pull is being split. Just an idea of what they look like. We get the blue around the side here is that, once again, that tidal bulge. It's just a different look at the same diagram.